Welcome to ZoomInData, your go-to channel for in-depth Azure Cloud, Serverless, and modern development interview preparation. In this video, we dive deep into the top 25 Azure Functions triggers and bindings interview questions for 2026. Perfect for developers, architects, and anyone preparing for AZ-204 certification or Azure Serverless roles. We cover core mechanisms of triggers and bindings, declarative versus imperative models, input-output differences, cardinality, extensions, bundles, custom bindings, dependency injection, debugging, performance impact, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What are triggers and bindings in Azure Functions? Triggers are the events that cause a function to execute, defining how and when the function is invoked. Bindings provide declarative connections to external resources, handling input data and output results without imperative code. Together, they enable event-driven execution with seamless integration to Azure services and external systems. Bindings eliminate boilerplate code for common operations like reading from storage or writing to databases. 2. Explain the difference between input and output bindings. Input bindings supply data to the function from external sources before or during execution. Output bindings send data from the function to external destinations after execution completes. A single binding can support both directions, in, out, depending on configuration and trigger type. Input bindings populate parameters. Output bindings use returned values or explicit assignment. 3. How do declarative bindings work? Declarative bindings are defined via attributes, C#, or function, JSON properties without writing connection code. Runtime automatically resolves connections using app settings or managed identities at startup. Platform handles data serialization, deserialization and error handling for binding operations. Enables clean, focused function code centered on business logic rather than infrastructure. 4. What is the attribute-based binding model? Attribute-based model uses .NET attributes on function parameters to define trigger and binding configuration. Common attributes include function name, HTTP trigger, blob trigger, queue output. Attributes specify direction, connection, path patterns, and other binding-specific properties. Preferred for compiled languages, C#, Java, due to compile time validation and IntelliSense support. 5. How do you define multiple triggers in one function? Azure Functions supports only one trigger per function to avoid ambiguity in invocation source. Multiple input-output bindings are allowed alongside the single trigger. For multiple event sources, create separate functions or use event grid fan-out pattern. Durable functions orchestrators can coordinate multiple triggered activities indirectly. 6. Explain binding expressions and direction. Binding expressions use syntax to reference app settings, trigger metadata, or system values dynamically. Direction specified as in-out or in-out in function, JSON or via attribute type. Input direction in populates parameters, output out writes results post-execution. Expressions resolve at runtime for flexible configuration across environments. 7. How do bindings support dependency injection? In isolated worker model, Bindings integrate with .NET dependency injection via constructor injection. Extension methods register binding services in startup configuration. Enables testing and composition with interfaces for binding clients. Traditional in-process model uses static binding resolution without die. 8. What is the cardinality of bindings? One versus many. Cardinality defines whether binding returns single item or collection. One versus many. Many, cardinality uses I enumerable less than T greater than or I async collector for batch processing. Trigger cardinality affects scaling, e.g., batch queue processing. Output bindings support multiple values via I async collector for bulk operations. 9. How do you create custom bindings? Custom bindings built using Azure Functions binding extension SDK for new data sources. Implement iBinding provider and related interfaces for trigger, input, output behavior. Package as NuGet and register via extensions, CS project or bundle. Advanced scenario for unsupported services or proprietary systems. 10. Explain imperative bindings in code. Imperative bindings allow runtime definition using binding builder APIs instead of declarative attributes. Useful for dynamic trigger selection or conditional binding creation. Available in isolated worker model with iFunction bindings feature. Provides flexibility at cost of compile time safety. 11. What is the role of iAsync collector? iAsync collector enables asynchronous batch output for bindings supporting multiple items. Add async method queues items for efficient bulk write at function completion. Automatically flushes remaining items on disposal. Preferred for high throughput scenarios like logging or data ingestion. 12. How do bindings handle retries? Retry policies configured per binding with fixed or exponential backoff strategies. Supported on triggers like queue, event hubs, and service bus for transient failures. Max retry count and delay intervals customizable in binding attributes. Poison message handling routes failed messages after max retries. 13. Explain binding data types and conversion. Bindings support primitive types, POCOs, strings, byte arrays, and stream types. Automatic serialization, deserialization using JSON or binary converters. Custom converters implement iConverter for specialized types. Type matching ensures seamless data flow between trigger and function parameters. 14. How do you pass data between bindings? Return value from function automatically assigned to output bindings when configured. Explicit parameter assignment for multiple outputs using out/ref parameters. Trigger data passed to output via binding expressions referencing trigger metadata. Durable functions explicitly pass data between activities. 15. What is the trigger metadata parameter? Trigger metadata provides system-generated properties like invocation ID, timestamp, and trigger-specific details. Available as additional parameters marked with trigger metadata or sysObject. Enables dynamic routing or logging based on trigger context. Commonly used in generic webhook handlers or diagnostic functions. 16. How do you debug binding issues? Check application insights for binding errors and dependency failures. Enable detailed logging in host. JSON for binding lifecycle events. Local debugging with core tools shows binding resolution at startup. Validate connection strings and app settings configuration. 17. Explain binding extensions and bundles. Binding extensions are NuGet packages providing trigger, input, output implementations. Extension bundles pre-package common extensions to reduce deployment size and startup time. Configured in host. JSON with version range for automatic updates. Recommended over manual extensions. CS project for most scenarios. 18. How do bindings affect cold starts? Extension loading during startup contributes significantly to cold start latency. Bundles reduce download time compared to individual extensions. Premium plan pre-warmed instances eliminate binding initialization delay. Isolated model improves extension loading performance. 19. What is the order of binding execution? Input bindings execute before function code runs. Function code executes after all inputs resolved. Output bindings execute after function completion, or return value. Trigger binding always first among inputs. 20. How do you handle binding errors? Binding errors throw exceptions during startup or execution, failing the invocation. Retry policies on supported triggers handle transient binding failures. Custom error handling in function code for recoverable issues. Application Insights captures binding-specific dependency failures. 21. Explain the new bindings SDK model, V4. V4 introduces extension bundle standard and improved isolated worker support. Unified binding SDK across languages with better extensibility. Enhanced middleware and imperative binding capabilities. Streamlined registration and configuration model. 22. How do bindings support async streaming? Bindings support async enumerable for streaming large datasets efficiently. Blob and HTTP triggers support stream input for memory-efficient processing. Output bindings support streaming responses in HTTP scenarios. Reduces memory pressure for large payload handling. 23. What are the most commonly used bindings? HTTP trigger for APIS, timer for scheduled tasks. Queue trigger for reliable messaging, blob for file processing. Cosmos DB for NoSQL change feed, event grid for events. Service bus for enterprise messaging patterns. 24. How do you version bindings? Binding versions managed through extension bundle ranges in host. JSON. Pin-specific versions for stability in production deployments. Runtime version, ~4, ensures compatible binding extensions. Monitor release notes for breaking changes during upgrades. 25. Best practices for designing triggers and bindings. Use single trigger per function. Multiple bindings for input, output. Prefer declarative attributes over imperative for maintainability. Leverage binding expressions for environment-specific configuration. Implement retry policies and idempotency for reliable processing. Thank you for watching. If this video helped you prepare for your Azure Functions interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth cloud computing, serverless, and Azure interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.